Welcome to our channel Sankalp Study Success. In this video, we are going to learn how to convert or how to construct finite automata for the given regular expression. That means we are going to convert regular expression into a finite automata, that is NFA. So now let us see. Here we are going, just now I have said that regular expression is going to convert it into NFA, that is NFA with epsilon transitions. We are going to convert regular expression to NFA with epsilon. So we have already learnt in the first chapter how to convert NFA with epsilon to NFA without epsilon transitions. So then we have also learned how to convert NFA to DFA. And in the further chapters, that means in the second chapter, for the further topics, we are going to learn how to convert DFA to regular expression. So this is a cycle where you are going to convert regular expression to NFA with epsilon, then NFA with epsilon to NFA without epsilon, then NFA to DFA, and also we are going to convert DFA to regular expression. That means it is a cycle. So all these four conversions are the most important for our external exams. We are going to concentrate from the first and second chapter. Mostly we have to concentrate on the conversions from one automata to another automata or from one automata to the regular expression. Now let us see. In this video, we are going to see the conversion from regular expression to NFA with epsilon. So now going ahead, here let us consider R be a regular expression, then there exists an NFA. If there is a regular expression, you can surely draw an NFA for the given regular expression but with epsilon transitions. So we are going to see it in two steps, that is basic step and the induction step. So here, if you have zero operators, that means you can have epsilon, you can have phi, or you can also have a. That means what? For the first case, R is equals to epsilon. Epsilon means we are not applying any input symbol. That means whatever the state you are going to take, that is the initial state and that will only become the final state. So this is nothing but R is equals to epsilon. Or if you take R is equals to phi, that means the same state is not the final state because it is not epsilon. So phi means we are not going to apply any input symbol, but there is an initial state and there is a final state, that's it. That means what? Q0 is the initial state and Q1 is the final state. But we are not going to apply any input symbol on any of this state and we are not going to move from one state to another state also. So coming to the third one, R is equals to A. That means what? It starts from the initial state and by applying A, it is going to the final state Q1. So by applying A to Q0, it is going to final state from the initial state. So this is the first step which we do. And coming to the induction step, that means here we have applied zero operators. But from the next time we are going to apply n number of operators. If you apply n number of operators, then we are going to get three cases which are union, concatenation and clean closure. That means these three are the three cases which we are going to have it. Then if you follow these three cases, you are going to convert your regular expression into NFA with epsilon transitions. So what is union, what is concatenation, what is clean closure? Now let us see one by one. Here the first case is the union case. That means what? If your regular expression, it is of the form R is equals to R1 plus R2, then you will be having two finite state machines M1 and M2 in such a way that L of M1 is equals to L of R1 and L of M2 is equals to L of R2. That means what? R1 regular expression is going to be accepted by the machine M1 and R2 is going to be accepted by the machine M2. So now let us see what are the cases which we need to follow. Here transition function of Q0 comma epsilon is equals to Q1 and Q2. That means By applying epsilon to the initial state, it goes to Q1 as well as Q2. Here, let us draw the diagram simultaneously. By starting with the initial state Q0, you are going to Q1 as well as Q2. By applying what? We are applying the input symbol as epsilon. So we went to Q1 and Q2. Now coming to the second one, transition of Q comma A. Then it moves to transition 1 of Q comma A for Q in Q1. That is, and also Q1 minus set of F1. That is what Q1, and we are having set of F1 also. By applying the second another transition function, that means any input symbol, by applying any input symbol we are going to have it. So Q1 by applying F1, and also here Q comma A, which is nothing but transition 2 of Q comma A for Q in Q2, that means nothing but Q2, right? So minus F2, that means what, here we are going to have F2. So by applying transition function to Q2, that means by applying any input symbol to Q1 and Q2, we are going to another states. So again, from this F1, we are going to apply epsilon, then it goes to F0, and also for F2, if you apply epsilon, it goes to F0. That means here there is a final state F0, and if you apply the epsilon to F1 and also epsilon to F2, it moves to the final state. So this is our transition diagram for the union case. That means if an expression is of the form R is equals to R1 plus R2, then our transition diagram will be in this format. So this is the first case. If you see the second case, that is concatenation, where the regular expression R is of the form R1 R2, then here you will be having two finite state machines, which are M1 and M2, which you know exactly. Then how the mapping function takes place. Here, see, transition of F1 comma epsilon goes to Q2. That means what, there is an F1 and another state Q2, right? So by applying epsilon, it moves from F1 to Q2. This is one transition. The second, transition of Q comma A is equals to a new transition of Q comma A for Q in Q1 minus F1. That means Q in here, Q1 minus F1. That is, here we are going to have Q1, which is the initial state, right? Which is the initial state, and here this is the finite state machine. That means if you apply any input symbol in R1 and R2, then you are going to have it in this format. And also this is the second transition function Q2 for Q2 minus F2. That means F2, which is the final state here, and you are going to apply the transition function here. So that means what, this is R1 and this is R2. If you are going to concatenate R1 and R2, you have to concatenate using epsilon. That means from R1, if you apply epsilon, it goes to R2. So let us have one example for this, which is R is equals to 0, 1. That means what, R is equals to 0, 1 is nothing but it is a concatenation example, that is of case 2, which is of the form R is equal to R1 and R2, right? So here we are starting with an initial state Q1, or you can also start with Q0. By applying 0, it moves to Q2, which is nothing but for 0. And for Q3, if you apply 1, it moves to Q1. This is nothing but for 1. And if you need to concatenate this 0 and 1, you have to concatenate using epsilon. So in this format, then this Q4 will become the final state. Like this, you need to solve for the case 2, that is concatenation. Now let us see the last case, which is clean closure. For this clean closure, if R is equals to R asterisk, R is equals to R1 asterisk, if it is of this format, then what does it happen? The transition function, mapping function will be, this is transition function of Q0 comma epsilon. That means for Q0, if you apply epsilon, then it moves to Q1 and F0 also. That is Q1 and F0 if we have. it moves to this Q naught by applying epsilon, and it also moves to F naught. Then for F1 comma epsilon, that means for F1 also, here if you have F1, it moves to F naught by applying epsilon, and also it moves to Q1, right? That means here by applying epsilon. So now transition of Q comma A, that means here you have applied epsilon, so you have got the moves. But here if you are applying A, that means any input symbol, then it will be having another transition function 1, which is Q comma A, where Q in Q1 minus F1, that is Q1 minus F1, here you are going to have it if you are applying any input symbol. So for example, if you take R is equals to 0 asterisk, if R equal to 0 asterisk, then this all will be same. Here you are going to apply 0. That's it, right? Q naught. This is the initial state. Here also it is the initial state, and it is moving to Q1 by applying epsilon. And we are having F1 and F naught, which are the final states, and the initial state is Q naught. Here you are going to apply epsilon, and here also. But here you are having 0. That means from Q1 to F1, if you apply 0, then it moves from Q1 to F1, right? So in this way, we are going to solve for union, concatenation and clean closure. So by using these three cases, you can convert regular expression to a finite automata, which is nothing but NFA. So let us convert one regular expression to NFA. So we will come to know what is what, how to convert it. The procedure also will come to know. So now let us solve a question. Construct NFA for regular expression B plus BA star. That means what? Given R is equals to, that means regular expression is equals to B plus BA star. So here if you carefully observe, it is of the form R is equals to R1 plus R2, which is nothing but the union case in the first case, right? So what is R1 here? R1 is equals to B and R2 is equals to BA star, that is BA asterisk. So for R1 equals to B, let us draw the transition diagram as Q naught. It is going to Q1 by applying B, right? This is nothing but for R1. Here if you consider for R2, which is of the form R3, R4, right? Where R3 is equals to B and R4 is equals to A asterisk. So for R3, if you draw, then you will get it as Q3, Q4, where it is moving from Q3 to Q4 by applying B, right? Here. Now, here for R4, here if you carefully observe, if it is of the form R4 is equals to R5 asterisk, right? So R5 is equals to R4 is equals to R5 asterisk, where R5 is equals to A. So for R5, if you draw, then you will get it as Q5 to Q6 by applying A. Right? It is of the form Q5 to Q6 by applying A. Now, you need to find out R5 asterisk. That means here let us write R5 asterisk. It is nothing but by using the third case, which is the clean closure. Now you have already Q5 and Q6 for R5, right? So let us write Q5 and Q6 by applying A. It is moving from Q5 to Q6. Now, from the clean closure, we were having Q7 and Q8 also. By applying epsilon, correct? We have applied epsilon here and here. This is nothing but R5 asterisk, right? Let us recap it once more. By using this formula, we are going to find out R5 asterisk. So these are the same thing which we have applied for epsilon, but here we are going to apply A because R5 is equals to A asterisk. So now we are done with R5 asterisk, but here we are going to have R5 asterisk is nothing but R4. So here you have to concatenate R3 and R4. That is, this is R3 and this is nothing but R4. So you have to concatenate both. That means what? Using the case 2 concatenation, we are going to concatenate both the strings. So we are going to get R2. So for R2, which is equals to R3 and R4. So R3 is nothing but Q3 and Q4 by applying B. So Q3 and Q4. Here we are going to apply B. Then what is R4? Let us write it here. Q7, Q5 by applying epsilon. Q5 to Q6, then Q8. Here also we applied epsilon. So let us write it as it is first. Now, in order to concatenate both R3 and R4, just we are going to concatenate by using epsilon, right? So this is nothing but R2. Now, we have to also find R1 plus R2. That is what? Using case 1, which is union. R is equals to R1 plus R2. So here R is equals to R1 plus R2. So what is R1 actually, which is equals to B, Q0 and Q1. So now let us write here Q0 and Q1, where from Q0 to Q1 you are applying B, so it is nothing but R1. And what is R2, which we have just now wrote this, so let us write it here R2, Q3 and Q4, Q3 and Q4 by applying B, then Q7, and also we had Q5. Here we have applied epsilon, and here also we have applied epsilon. Let us write it as it is. Q8 by applying epsilon, and from here also we applied an epsilon. So this is the R1 and this is R2, right? So how do you union of those two? How do you find the union of R1 and R2? So here by applying Qi, which is the initial state, you can apply anything by applying epsilon to this. And also if you apply epsilon to this, and also if you consider Qf, which is the final state, and if you go to this final state by applying epsilon, then this is nothing but the union, which is R is equals to R1 plus R2. So this is NFA with epsilon transitions for the given regular expression. So in this way, by using those three cases, union, concatenation, and also using clean closure, we are going to find what is NFA for the regular expression. Now let us solve one more question so that we will be much more clear in order to convert regular expression into NFA. Here, construct NFA for regular expression 0 plus 1 whole asterisk, which is nothing but, let us consider R is equals to 0 plus 1 whole asterisk. It is of the form R is equals to R1 asterisk, right? Here, R1 is nothing but 0 plus 1. That means we can say that it is of the format R1 is equals to R2 plus R3, right? So what is R2, which is equal to 0, and R3 is equals to 1? Here R2 is equals to 0 means what? Here if you consider Q1 and Q2, so from Q1 if you move to Q2 by applying 0, then it becomes R2. And here if you take Q3 and Q4 by applying 1, it moves from Q3 to Q4, right? You got it as you got R2 and R3. So you have to find what is R1. R1 is nothing but the union of R2 and R3, which is of the first case. So now let us write R2 and R3, Q1 and Q2 by applying 0, and Q3 and Q4 by applying 1. Now, how do you take the union of these? Here, let us take Q0 as the initial state. By applying epsilon, you are moving to Q1, and here also by applying epsilon, you are moving to Q3. Here, let us take Q5. By applying epsilon, you are moving from Q2 to Q5, and by applying epsilon, you are going from Q3 to Q5. this is nothing but R1, and the main thing we are going to find is nothing but R is equals to R1 asterisk. Then you are going to get the NFA for given regular expression. So what is R is equal to R1 asterisk? That means R is equal to R1 asterisk. For this you are going to find the asterisk. That means let us write this R1 as it is here, Q0, Q1 to Q2 if you apply 0, and here from Q3 to Q4 if you apply 1, right? Then from here you are going to apply epsilon, and here also you are going to apply epsilon, and this is Q5. This was our R1 exactly. So in order to find R1 asterisk, let us take Qi as the initial state here and Qf as the final state here. So now if you apply epsilon here, and also if you go to Qf, sorry, this is not F, right? It is epsilon. So here it is epsilon, and from Q5 to Qf also we are going to apply epsilon, and from Q5 to Q0 it is epsilon. So in this way we are going to find the NFA for the given regular expression. So by using three cases: union, concatenation, and also the clean closure. This is nothing but the NFA with epsilon for given regular expression. Now let us see what are the applications of regular expression. Regular expressions can be used in the Unix operating system. The first thing is you can use in the Unix operating system, and in the command prompt if you use these regular expressions, that means the expressions, you can find the files, and you can, in order to search, you can find out, you can use regular expressions, and this symbol is used for the beginning. Okay, and here the regular expression also consists of meta characters. Just now in the regular expression we have seen plus and asterisk, right? Because asterisk is nothing but 0 or more occurrences, and plus is nothing but 1 or more occurrences. So this dot represents any character, and question mark represents 0 or 1 occurrence. So in this way we are going to have some of the meta characters in the regular expressions. And the second one, the application of regular expression is, it is used in the lexical analyzer. It is used in lexical analyzer. Here, or scanners also. It scans your document. Lex tool is used to identify words in the document. So it will see the words in the document. It is one of the application of regular expression. And also for finding the patterns in the text, we are going to use these regular expressions. So these are some of the applications, because as applications can be asked for 2 marks questions, so you can focus it here. And also let us see some of the algebraic laws for regular expressions. We are having some algebraic laws for this regular expressions. The first one is commutative law, where L plus M is equals to M plus L, which satisfies over union. That means regular expression satisfies over union, and it will not satisfy over concatenation. That means L into M is not equals to M into L for the regular expressions. For regular expression, commutative law is only true for the union but not for concatenation. And coming to the associative law holds true for union as well as concatenation. That is L plus M plus N is equals to L plus M plus N. And also it is also true for concatenation, where Lm of N is equals to L of Mn. So associative law is true for both the cases, union and concatenation. Here distributive law is also true for union and also true for concatenation. That means it satisfies over concatenation of union. It satisfies over concatenation of union, but it is the left distributive and this is the right distributive. That means L of M plus N, which is nothing but the left distributive, but L plus M of N is nothing but the right distributive. So it is true, it satisfies over concatenation of union. And here coming to the identity law, phi is identity element over union and epsilon is the identity element over concatenation. Phi for union and epsilon for concatenation. So then coming to the annihilator. What is an annihilator? Annihilator, you can get it for 2 marks question, which is an important thing. What is annihilator is L into phi is equals to phi into L, then you will get it as phi only, and this phi is nothing but annihilator element over concatenation. Phi is known as the annihilator over concatenation. And coming to the idempotent law, which is nothing but L plus L is equals to L, so it says idempotent law is also true for regular expressions. And closure laws, where L asterisk whole asterisk is L asterisk, epsilon asterisk is epsilon, phi asterisk is phi, and L plus is equals to L asterisk or L asterisk L. Both will be equal to L plus, and L asterisk is equals to epsilon plus L plus or L plus epsilon. You will get both as L asterisk. And here L with question mark, here it is L with question mark, which is equals to epsilon plus L. These are some of the algebraic laws for the regular expressions. So you need to remember what are satisfying under union and what are satisfying under concatenation. Thank you for watching the video.